So in this discussion, we are going to look at a problem on circular motion, and we are told that a circular automobile test track has a radius of 200 meters. So from the center to here is 200 meters. The track is so designed that when a car travels at a speed of 90 kilometers, so V is equal to 90 kilometers per hour. So we multiply it by 1,000, we divide it by 3,600. So 90 exponent 3 divided by 3600, we get 25 meters per second. The force between the automobile and the truck is normal to the surface of the truck. So find the angle of banking. So if this is level, we are told that the truck is at an angle of banking, and we are told that the reaction between the centrifugal force mv squared out of r and mg, which is vertical, okay, that reaction r is normal to the surface. So if it is normal to the surface, then that means there is stability here, and therefore we shall use the fact that tan theta is equal to v squared out of rg. We already know this from one of our discussions, and therefore we shall just substitute in. So this becomes 25 squared divided by the radius, which is 200 times 9.81. So we can get theta equal to arctan of 0.31855, and this is going to be 17.67 degrees. So the angle of banking here is going to be 17.67 degrees for the resultant between the weight of the body and the centrifugal force to be normal to the surface, or to be normal to the truck at the point where the wheels or the tires of this automobile are going to be in contact with the ground. So that is it. So ladies and gentlemen, in this discussion, we are looking at superelevation in railways. So the distance between the rails of the truck is 1.67 meters. How much the outer rail be elevated for a curve of 500 meters radius in order that the resultant force may be normal at a speed of 45 kilometers per hour. So the speed V is 45 times 10 power 3 divided by 3,600. And this gives us 12.5 meters per second. The R is 500 meters. So here we are talking about a railway, and we are talking about superelevation. So superelevation is going to be the elevation between this inner rail and the outer rail. So this is the superelevation we are talking about. Let me call it S. But we know that S is actually equal to G V squared out of small gr. So G is the gauge of the rail, then V is the speed, R is the radius of the truck. So if you always hear that the gauge, this is a meter gauge, then that means this gauge G is equal to 1 meter. If it is 1.67, this is a 1.67 meter gauge railway. So let's look at our superelevation. S will therefore equal to 12.5 squared times 1.67 divided by 9.81 times 2 times 500, because the radius is 500. So this is equal to 53.198 millimeters. So that is going to be the super elevation of the gauge of the rail, or the super elevation between the outer and the inner rails of this railway.